to allow you in. Hello, David. Can you send a message to their group so that they start joining? Um, Glory said her network is her laptop is moving, but she might join us late, but she'll join very soon.
So you said that what? What did you say? You say something, Wafa. Elvis.
Yeah, Glory will join us very soon. Her laptop is keeping long to boot, but she'll join us soon. So kindly remind them in the page that the session is starting so that they can join. Tag all of them if possible. Yeah.
For Telegram, I'm not sure. I just tried that. It isn't working. Yeah, so I've already typed in the group that it is time. So I think let's say by 9:10 or before 9:10, I'll go into the group again and remind them. But what about the others? Jim, Wisdom, Bismarck. I'm not seeing anyone on the call right now. Hello, can you hear me?
Yeah, I can hear you. Yeah, I've not heard
Yeah,
from
I
the
said
others.
that.
I've not heard from the others too.
Oh, okay.
And then let's see. We're just waiting for Glory to join. If she join, at least we can start the session. I want to take up something and come and join soon. My phone, I'll join my phone.
Okay. You are all welcome to our third section. Please let's wait for some few minutes. By 9:15, we would like to kickstart. But since some of our colleagues haven't joined yet, let's exercise patience as we wait for them, as well as our resource person who's here to join us on the call. So thank you very much for joining us this evening. And I want you to just play around, hang around, and wait for our resource person and our colleagues as well. Thank you. Hello, Ferdinand. Ferdinand, are you there with us? If you are here with us,
Yes, I'm here.
okay. Edu Jemfi, are you here with us? Okay, that's great. So I know we paused for some time. We are now back, and I want to hear from you how far so far what you have done, the concepts, the beginning of the boot camp. what have you been doing with it, with the practice that we have shown to you guys? What have you been able to do? Are you making practice of it, or you have also paused since you have also paused? So I want to hear from you guys, and also how far with your eyes. And I know we are still in the IE week for some students. I don't know if you have finished or not. So I would like to hear from your academic side as students, as well as our bootcamp session. What you have, what you have been doing since we paused during the IE periods. So I'd like to hear from you, Edu Jemfi. Any one of you can go first.
Okay, so first of the IA for me, we haven't started yet. My first IA will be next week, Saturday. That's when I'll start my IA. Then the machine learning, I went ahead to learn about the supervised learning model. Yeah, so that's what I've been up to. I learned the supervised learning, yeah, the types, the regression and classification, and also some, yeah, I started learning the regression line, and yeah, that's that's what I've been up to.
Oh, okay, that's great. That's great. Going further to learn on the supervised method. I think that's a step that you're also making towards your machine learning course. With that said, are you a fresher? Edu GMV.
Yes, I'm 1100.
Oh, okay, okay. Nice meeting you. And you are
Thank you.
welcomed to the. So you are doing specifically computer science or what?
Actuarial science.
Oh, okay, okay. Our resource person is in now, Miss Glory Akoto Elizabeth Enfua. You are welcome, Miss Glory. Please, if you are there, kindly react or let us hear from you.
Yes, please. Good evening. Good evening.
It's
Please, am
been
I
a while.
audible? Yes, it's been a
I think.
while. I trust you are doing well.
Yes, please, and you.
I'm also fine by God's grace.
Okay,
Good.
okay.
So I'm sorry I'm late. I had some technical issues. So I had some technical issues. So right now it has been resolved. So by God's grace, we can start.
Okay, okay. So please, I want us to share the link on our statuses, share the link to our friends, invite them to join us so that we kickstart. Our resource person is in now, and in the next few minutes, we'll be starting. So kindly share the link, invite your friends wherever they are, call their attention to join us as we continue our session for the boot camp. Yeah, I think that's logging me out. Once again, I want to welcome you all. Yeah, hello, can you hear me now?
Yeah, we can hear you. I think Gloria has joined now.
Okay. Okay. So please, if you can hear me, kindly react. Kindly react. So please, I want to welcome you once again as we continue from where we have left off. So you are welcomed, Edu Jemfi, Ferdinand, Sakibu, our resource person, Miss Glory, and Elvis Nkrumah. So we continue from where we left off, and today we'll be focusing on our first machine learning models. Yes, previously we dove into machine learning, its type as well, where we learned about supervised learning and unsupervised learning. So today we are going to focus on our first machine learning models. And our speaker is a friend of ours, an alumni now, who read computer science and mathematics. And her name is Miss Glory Elizabeth Efua Akoto. Please, I want us to welcome our resource person as she takes us for this session. Kindly react, kindly welcome our resource person as she takes the lead. Thank you very much. Miss Glory, if you are there, you can take control now.
Okay, thank you so much, David. Thank you for the opportunity, Elvis and David. Please, am I audible? Am I audible?
Yes, please. Yes, please.
Okay. So, thank you so much for the opportunity, Elvis and David. Um, I'm happy to take this section because these are one of my favorite areas in computer science, actually. So, by God's grace, you are in good hands, and we would not take too much time. We'd like to begin immediately. So today we are doing supervised learning fundamentals. So let me just share my screen and start. Please, can you see my screen? Okay, I think I'm sharing the wrong thing. I'm coming. Hang on. Please, can you see my screen now? Am I audible?
Yes, please, you are audible. We can hear you. And your
Okay. Were
screen
you
as
able
well,
to
we can
see
see.
my? Okay. 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 So today we are doing um supervised learning. We are starting with supervised learning, and this is under machine learning, and there are two types of ways a model can learn from data. And so we have the supervised, there are actually three types of ways. We have supervised learning, we have unsupervised learning, and then we have reinforcement learning. So let me just run through these three things and then we'll start with supervised learning. So for supervised learning, as the word supervised goes, is like training a model and guiding the model to learn. So for example, if you have a model and you are feeding it with data, you feed it with the target data. I don't know how far we have gotten to in machine learning, so I'll try to be as basic in my language as possible. So the target data is what we are trying to predict. So for example, if we have prices of houses, and we have the size of the house, we have the location of the house, and then we have the price of the house. In this particular data set, what we are trying to predict is the price of the house. So when we are feeding the model with data, we will feed the model with data that includes the prices of the houses in that data set. And so that is supervised learning. And so feeding it with the target variable, that's the price, is feeding it with labeled data. But in the case where you don't feed it with labeled data, that is unsupervised learning.
Hello, Glory. Miss Glory, please, are you there? Please, we cannot hear you. We can't hear you. Hello, Miss Glory. Please, I want us to assess patient as a resource person reconnects to join us soon. Please hold on as I get to the resource person. I want to try to reach her to see if she can join back. So please hold on.
Hello everyone.
Hello, Miss Glory.
Yes, I'm sorry, my
You are
line
welcome back.
dropped. Thank you. Thank you. Okay, so I don't know where you lost me, but I think I started speaking on supervised learning. So as I mentioned earlier, supervised learning is training a model and guiding the model to know which one is the target variable and which ones are the features. So you are teaching the model in such a way that it knows the answer. That's for the training data. It knows the answer. And so it's simply training an AI using labeled data. That's the questions and then the correct answers. But in the data set, we would call it the features and then the target variable. So the features are the parts of the data that helps the model to predict what we are looking for. So like the example I mentioned earlier, for the house prices, you need the size of the house, you need probably the number of rooms the house has, and you will need the location of the house. So for example, a house in Ghana here at Airport Residential Area, the price will be different from a house in Adenta. A house in Trasaco, the price will be different from a house in Medina. I'm supposing we are all Ghanaians. So these things are the features that helps the model to predict the price of the house. And so training it with the features, and it knows which one is the features and it knows which one is the target variable, that is labeling the data. So this kind of training is called supervised learning. So for example, if you have a data set, I've just given an example with the houses, but for example, if you have a data set containing patients, information about patients, to know whether they are probably anemic or they are not anemic. So for example, whether this particular patient lacks blood or another patient does not lack blood. So you can see some symptoms in a patient that lacks blood. For example, the person easily falls weak. The person usually has red palms. Inside their palms is red. That's an example that somebody is anemic. So maybe you can check your palms right now and see whether you're anemic or not. That was just by the way. But these things are features that helps the model to identify whether this patient is anemic or not. So supervised learning is you are feeding the model with data such that it knows that for that particular training data, it knows that for so and so features, if the patient's palms are anemic, if the patient easily falls, becomes weak, that means this patient is anemic. And if, sorry, okay. So, and if a patient does not have red palms, and then a patient does not easily fall and become weak, that means that particular patient is not anemic. So with the way you present the data to the model, it will help it to predict on a new data set that, oh, this particular person is either anemic or not based on the data it has received. So that is supervised learning. So telling the model that for these particular features, that is the red palms and then a patient easily falling weak, means that the person is anemic. That means you are labeling the data. That is what we call labeled data. You are presenting the model with a data set where it knows the target. That is what we are trying to predict, and it knows the features. That is what it uses to predict the target. That is labeled data. So training a model with labeled data is called supervised learning. And so under, I misspelled verses, sorry. Under supervised learning, we have regression and then we have classification. Okay, so there are two types of models under supervised learning. So there are two scenarios, but before we even begin, let's explain what regression is and what classification is. So first of all, what's regression? Regression is predicting a continuous quantity. So for example, my final year project was on predicting a student's score at the end of the semester. So for example, if you pick a student like Kofi and he studies for 5 hours every week and he solves about 10 past questions for that particular subject in that semester, and what other features did I use? Study hours, the number of questions he solves. I've forgotten the rest, but we can even use just these two. You would end up getting a continuous variable as your result. So for example, if you put in all these features, you can get a result like Kofi is going to get 80% in this particular subject at the end of the semester. So that is a continuous variable. That's a continuous value. And it's called a variable because it changes. For every prediction you make, it might be different if you put in different features. So as I explained earlier, the features are the things that help us to predict the targets. And the target is what we are looking for. So in this case, we are looking for the students' final score in exams. And then what we are putting in is the past scores. So for example, if Kofi previously scored 90% in the IA, and then Kofi spends about 10 hours learning a week, and then Kofi solves about 10 past questions before the exams time, and Kofi is highly motivated to study. And there was a fifth one, I don't quite remember. All these things, you are able to tell, the model is able to tell the results that Kofi will get, and it's going to be a continuous value. So there are times where you put in different features and then it's going to give you a different value. So for example, if you put in low features like your previous score was 50%, you don't like studying, you're not motivated at all, you don't even study any hours during the week, and you don't solve any past questions, certainly the prediction that you are going to get will be a very low prediction, like 20%. So because sometimes you get 20%, sometimes you get 30.5%, sometimes you get 50%, sometimes you get 90%, it varies. And it's a continuous variable because you can get any number at all. It's not a discrete variable. A discrete variable is either red, blue, or black. So you get one of these classes, either red or black. But for a continuous variable, you're going to get numbers. Yes, you're going to get numbers. So that is regression. Regression is predicting a continuous quantity. Example is exam score, your weight. What again? Yeah, most of those things that they predict, like house prices. You can get any value at all. Yes. So that's regression. And then classification, on the other hand, is predicting a discrete class label. So a discrete class label is, for example, you have a set of features to determine whether an email you get is spam or is not spam. Yes or no. Those are discrete classes. It's either yes or a no. So that's classification. So today we are focusing on regression. We are going to focus on regression. So I started with supervised learning, and then I went down to the types of supervised learning, that's classification and regression. And I mentioned earlier that supervised learning is training a model under guidance, that's labeling the data and giving it to the model to learn. And a discrete class like yes or no or red is either fair or dark, or you're in the middle, you're chocolate. Okay, either fair, chocolate, or dark. Those are discrete classes. And then for regression is predicting a continuous quantity, like your weight and then the house prices. These are ways together. Okay, so under regression, we have two types. Okay, we have linear regression and then we have logistic regression. So for linear regression, it's a way to predict a variable. So let me introduce some new terms. We have a dependent variable and then we have an independent variable. So a dependent variable is the target. For example, let me use the housing price, the house prices again. The dependent variable is the price of the house, because for you to get the price of the house to be 400,000, it depends on the area. So like this 400,000 Ghana cedis for a house, maybe around Oyarifa, you can get 400,000 cedis for a house, but around Twasako is eight is it 8 million or 8 billion? One of them. Around Twasako, you get $400,000, not Ghana cedis. Oyarifa, you get it in cedis, but in Twasako, you have to multiply it by 10. It's the same Ghana, but it's different locations. What even brought me to that? So I was talking about dependent variable and independent variable. So the dependent variable is the price of the house, and is dependent on the location, is dependent on the number of rooms, is dependent on what again? The location, the number of rooms, and the house. Okay, so the number of rooms would be will correlate to the size of the house. So I will not really add the size of the house. So let's just use the number of rooms and then the location of the house. The price that you have over here is dependent on these two things: the number of rooms and then the price of the size of the number of rooms and then the location of the house. So I received some good news this evening, so my mind is a bit, but I'll try to focus. So the dependent variable, that is the price of the house, is called a dependent variable because it's dependent on the location of the house and then the number of rooms that is in the house. Please, is that okay? So that's why it's called a dependent variable. But if we pick the number of rooms of a house, it's an independent variable because that number of rooms of the house is not depending on anything. It's the architect that chose to put 5 rooms in that house. It's not depending on any of the things like probably the location. You can get a house in Chasako for 3 bedroom. You can get 8 bedroom. It's the same location. It's not depending on the location. That's why the architect made it 2 bedroom or 3 bedroom. So the number of rooms is an independent variable. You can get a 2 bedroom at Transako You can get 2-bedroom at Oyarefa. So you cannot say because the location is Trasacco, that means the rooms are supposed to be more. No. That's why the number of rooms is independent of the other variables. It is totally independent. That's why you can get an 8-bedroom at Oyarefa for maybe let's calm down. A 4-bedroom at Oyarefa for 400,000, but you get 1-bedroom at Trasacco for 1 million Ghana cedis. It's because the number of rooms, the price, the number of rooms does not depend on the price or the location. Please, am I clear? Hey, please, am I clear? I would like to have an answer. Or you want me to explain further? Oh, am I clear? There is no response. This
Yeah, yes, yeah.
I want to know whether I'm teaching myself. Okay, so that's what we have. That's why we call some things dependence variable and independence variable. Yes. So back to the definition for linear regression. For linear regression, it's a method used to predict dependent variables based on values of independent variables. I'll take that again. Linear regression is used to predict dependent variables based on values of independent variables. And it's a linear regression because it has the formula of a linear equation. So we know a linear equation is basically mx plus c, right? Let me move down to that. That makes sense.
If you are talking 24 hours per year, you need to say you close. That's a 24 hours every hour. 24. So you need to say you close. If you Fridays, you close. Fridays 10 p.m. Now you start. You will be there yet. Okay.
Okay. So let's continue. So for the linear regression, it's named linear regression because it's based on a linear equation. You can retrieve a linear equation. The relationship between the features and then the target variable is a linear equation. That is basically it. So we know a linear equation is a linear equation is mx plus c. Mx plus c. So m is the coefficient, and then we have x, and then we have c plus, and we have c, which is the y-intercept. So let's take a typical example. I'll use the Oyarefa house again. So for example, if we have a 4-bedroom house at Oyarefa for let me take my pen. So we have a 4-bedroom house at Oyarefa, and let's start with a constant that if we have for every house that we have, whether it's a 1-bedroom, 2-bedroom, 3-bedroom, 4-bedroom, 5-bedroom, we still have to start with 1,000 cedis, 1,000 Ghana cedis. No matter how many bedrooms it is, we have to start with 1,000 Ghana cedis. And then for every one room, so the 1,000 Ghana cedis will cater for the kitchen and then the hall. So for every one room, is going to be an extra 1,000 Ghana cedis. So that would be a very cheap house. So for example, if we have a 0-bedroom house, there is no room inside the house, right? That means in that case, the x, so let's say the equation is mx plus c. The linear equation is mx plus c, right? And then the m stands for the coefficient. and then the X stands for the number of rooms. And then the C is the constant. So our constant is the 1,000 cedis. That no matter the number of rooms, we are putting 1,000 cedis down for the kitchen and for the hall. And then for every room, we will charge 1,000 Ghana cedis. So let's say we are renting a house. We are renting a house in Oyarefa. And for the kitchen and then the hall, the owner says that she will take 1,000 cedis for the kitchen and the hall. So we'll put that down as the constant, 1,000 cedis. So for the C part, that's 1,000 cedis. I wish I could write on the slides, but it's not possible because my laptop cannot help me to do that. So I'll try and explain it as best as I can so that we'll understand. So for every room, we will charge 1,000 cedis. So for a 1-bedroom house, it will be 1 times 1,000 cedis. So the 1,000 cedis will stand for the M. That's the coefficient. And then let's say the size is the number of rooms. The size that we see here. Let's put in number of rooms so that we'll understand what. Okay, so let me even make here. So rent is equal to the coefficient. That's for every 1 room, we'll charge 1,000 cedis. Then times. This time around, the first time we have only 1 room. Plus the 1,000 cedis that we put down for the kitchen and then the hall. That's 1,000. So in all, our answer will be equal to 2,000. But the case where we have two rooms, and we said for every room, we'll charge 1,000 cedis. So that will be times 2, plus the kitchen and then the hall that we have put down. So the answer will be 3,000 cedis. So this is how the relationship between the target and then the, what's it called? The features are. So we could have an instance where the madam says, oh, for the kitchen and then for the room, for the kitchen and then for the hall, I'll not take any money. So your equation, which is y is equal to mx plus c, the c will now become 0. So she will now be charging for just the rooms. Let's say she charges for the room and then she charges for a location. So let's say she has a house at Trasaco and then she has another one at Oyarefa. So we'll have mx1 subscript 1 plus nx subscript 2 plus c. But here the c is 0. So in that case, when we come to the rent, and she says the Oyarefa house, she will collect. For the Oyarefa house, she will collect 1,000 cedis for every room. So that's 1,000 times 1. And then I'm getting a little confused. I wanted to input 2 variables. That's the number of rooms and then the location. So for the first one, we have the number of rooms. So that's 1 times the 1,000. And then the location is Oyarefa. And then we go to Trasaco and she says that that place too, for every room, she will charge. Okay, so just because the location is Trasacco, she's charging for the room 2 for Oyarifa. Sorry, for Trasacco. So we have 2 rooms. So for the room is 1,000, and then for the location, she'll take 10,000. So you see that the results will be different results. You have different results based on the different features. So that was just an example I was trying to do. Okay, so that's linear regression. It's used to predict dependent variables based on independent variables. And most of the time, I would rather say all the time, the results you get will be a continuous value. So like the way you can see, all the results that we'll be getting from here are numbers. And numbers are a continuous value. Numbers are continuous values. Okay. So we want to move to logistic regression. So you see, for the regression, you are predicting continuous values. And then the difference between the linear regression and then the logistic regression is that for the linear regression, you are going to put in values that are, how do I put it? Like the house prices, the values can be huge, the values can be small, whatever value you put in, you will get the results that you want. And you get values like 400,000 CDs, 1 million Ghana CDs, and all those things. But for the logistic regression, you would want to get a probability between 0 and 1. And then the output you are going to get would be continuous at the beginning, but you can turn it into a categorical output. So for example, if you want to predict whether a message is spam or not, based on the features that you would use, you would be able to determine that this is spam and then this one is not spam. So let me give you an example that we can relate to. Most of us are university students, and then we have GPA. You see, there are times where after level 100, they'll tell you that if your GPA is less than 1.0, you have automatic withdrawal from the school. You have to withdraw yourself, else they'll withdraw you. It means you are no longer accepted in the school anymore. You are no longer accepted in the school anymore. So let's say the results you get will be a probability of whether you are going to stay or you're not going to stay. Is that okay? Whether you're going to stay or whether you're not going to stay. And so even though you can get something like your GPA can be 0.5, it will enter the category of not staying. If your GPA is 1.1, it will enter the category of staying. So let's say your GPA is 4.0. That means the probability that you are staying is 1. If your GPA is 0, the probability that you are going to stay is 0. You are going. If your GPA is 0.5, the probability that you are going to stay is going to be about probably 0.2%, 0.2. I'm just using my head to calculate it. What am I saying? Logistic regression is a way to categorize data into probabilities. And then probabilities are between 0 and 1. Even though it's continuous, you can get a probability like 0.55555. It's a probability. But you can set a threshold for that probability that anything I get from 1.0 and above it's a yes, this person will stay. Anything I get from, okay, that was a wrong example because probability is between 0 and 1. So if your GPA is 1.0 and you slice the probability, whatever you get, let's say if the probability is 0.5 to 1, that means the person is staying. If the probability is from 0 to 0.5, it means the person is leaving the university. That was a better example. So your probability can be continuous, but you can put it in a categorical form at the end. So mostly logistic regression comes out, the results come out as categorical values, either yes or no, is spam or is not spam. This person is staying or this person is going. It's either you buy or you will not buy. For example, if you're checking credit card, what's the word? Whether a credit card is eligible to take a loan. Yes, the person qualifies, or no, the person does not qualify. We use logistic regression. You use probability. So logistic regression is a method used to predict a dependent variable given a set of independent variables such that the dependent variable is categorical. So as I said, initially you are going to get a continuous value between 0 and 1. And then you will set a threshold that if the probability is above 0.5, that means predict it as yes. Else, if the probability is below 0.5, predict it as no. So even though, because it's a regression model, and regression models, as I said earlier, they predict continuous quantities. For the logistic regression, it's going to convert it from the continuous quantity into a discrete quantity. That's yes or no, because it's coming out as a probability. And for the probability, you are setting a threshold of 0.5. That if it's above 0.5, take it as a yes. If it's below 0.5, take it as a no. This, I hope I did not confuse you. You two, you did not confuse me. Okay. So I want us to strike some differences. I don't know whether we've got into that place. Okay, so this regression versus classification, but I want us to strike some differences between logistic regression and then linear regression. Okay, so let's look at the definition. So the only difference in the definition is that, as I said, the linear regression will give you a continuous result. The house price is 400,000 Ghana cedis, or the house price is 50,000 Ghana cedis. It is never going to be categorical. It will never be categorical. But for the logistic regression, even though the probability is continuous, the results they'll give you is either yes or no, either spam or not spam. So in the end, you are going to receive a categorical result. That's for the definition. So linear regression predicts continuous dependent variable based on values of independent variables, whilst the logistic regression, it predicts categorical dependent variables based on values of independent variables. Okay. So the second difference I would want us to strike is for the linear regression, your independent variables can either be continuous or discrete. So for example, my final year project, it was on predicting students' exam score performance. And for one of the features, that's the independent variables, it was how motivated you are. Are you very motivated to study? Or you are not too motivated to study. That one is a categorical variable. It's a discrete variable. It's either you are very motivated, you are not too motivated, you are in the middle, or yes, so the three of them. You are either very motivated, you are not too motivated, or you are in the middle. So that one is a discrete variable. And I also had some continuous variables like your previous score and then the number of hours you study. For linear regression, your features can either be categorical. So your features can either be continuous or discrete. It does not mind. It will end up giving you a continuous value. So you can put in either continuous or discrete values, and then it will end up giving you a continuous result. But for the logistic regression, your input, that's your features, they are supposed to be continuous, independent. They are supposed to be continuous. Your features are supposed to be continuous. So for example, the example I gave, the GPA example that I gave, for example, if me like this, okay, I'll not give myself as an example. Let's say somebody who had 4.0 after the first year. 4.0 is a continuous value. And you put it inside this model, and it strikes the probability that the person is staying, and then the probability you get is 1. So that means yes, the person is staying. Or maybe somebody got 0.1, the GPA was 0.1, and you strike the probability that whether this person is staying or not. And then your result is the person is the probability you get is 0.01. It means the person is not staying. The input is supposed to be continuous. The independent variables are supposed to be continuous for the logistic regression. And then the targets, let's track the difference in the targets. So for the linear regression, as I mentioned earlier, is always going to give you a continuous value. It's going to give you a number. It's always going to give you a continuous value. That's for the linear regression. But for the logistic regression, it's going to give you a binary number. It's either yes or no. It's either spam or not spam, but it's going to come out as a binary number, and then the model or how you program it to be will result in the exact answer that it's going to give you. But it's either yes or no. It's either buy or not buy, spam or not spam. So the result is a binary value. It's either 0 or 1. And based on how you code it out, you get the results that you want. Hey, it's fast time. Okay, so for the applications, linear regressions are used in business domains, like the housing prices that I said, in forecasting. The applications, you can use it in forecasting. And then for the logistic regression, you can use it in cybersecurity. Whether this person looks like the person is guilty or the person is not guilty. You know how cybersecurity works. So that is it for today. That's the theory part. That is it for today. So let's just move on to, okay, so let's talk a little bit about training and testing data. So we usually like to train our model in such a way that when it gets new data in the real world, it will be able to handle it. So for example, if I have prices of 100 houses, okay, and then I train the model on those 100 houses, and then I try to test the model, and I test it with data from those 100 houses, the model is going to come out very accurate. It's going to come out very accurate because you are giving it a quiz on, it's like you go to class and then you solve some questions in class, and then in exams it comes again. The exact same questions come again, and the lecturer does that to you from level 100 to 400. If you go out into the real world and then you get something similar, very similar to what you were quizzed on in class, you will not be able to do it because your brain is trained to solve it exactly the way you were taught. And you didn't have any other example to try it on, to try your mind on. It's the same with the model. If you train the model on all of your data sets and you test it on the same data set that you used to train it, it will perform very well for you to see. But if you take it to the real world to perform on data that it hasn't seen, it's not going to come out nicely at all. The model is not going to predict very well. So what we usually do is when we have the data set, you take 80% and use to train the model. And then the resulting 20% that it hasn't yet seen, you use it to test the model. So that when the model sees real world data, it's used to being tested on new data already. So it will perform the same way that it has performed for you, the developer, to see. So let's start with the linear regression. So this is a data set that has diabetes, information on diabetes patients. Okay, so first of all, we load the data into a function called load diabetes. This is not the full code. This is just a snippet for us to understand what we have done so far. So we've just loaded the data into the function called load diabetes. And then so XTR will stand for X train, XTE will stand for X test, YTR will stand for Y train, and then YTE will stand for Y test. And if you are not familiar with X and Y, X stands for the features, and then Y is for the target. The reason why we see X to be capital and then Y to be small is usually X represents a matrix, and the matrices are used labeled with capital letters, and then the Y represents a vector, and vectors are labeled with small letters. So that is what we have here. So the X is the features. So for your data sets, you have the features, that's the independent variable, and then you have the target, that is the dependent variable. So we are going to cut that data set into 80% for training and then 20% for testing. So X train is the 80% that we have cut out from the features. And then X test is the 20% that we have left out from the features to use to test the data. Y train is the same thing. The 80% that we have cut out from the targets to use to train the data, and then the Y test is the 20% that we have cut out from the targets to use to test the data. So we are using the train test split method, and then we put in X there and Y there. So X is the feature, the diabetes data set, and Y there is the target for the diabetes data set. The test size is 0.2. And 2 means that from the data set that we have, we are taking out 20% to use to test the data, and then we are leaving out 80% to use to train the data. And so we are naming our linear regression model, and so that's what we assign, what we will assign the fitted model to. So that's the link model. So we call a linear regression model, that's the linear regression we have here, and then we fit in the X train and then the Y train. We are fitting training data. And then lean pred is the predicted the predicted data. So we use our lean model to predict, and then we are going to lean pred. So what are we predicting? We are trying to predict the X test. So what we left out from the features, we are using the features in what we left out to use for the testing. And then we are using the model to predict it, and then we assign the results to lean pred. And so we are just going to print out in absolute error that we will get. So we are just going to compare the actual results, that's the actual targets that we would have versus what the model predicted. And then we will get how well the model performed in that particular prediction. I hope I explained it for you to understand. So the first thing is we are loading the data set. The second line is we are dividing it into data and then the prediction data. Sorry, we are into the training data and the testing data. And the third line is we're calling the model and then we are fitting it in. We are putting the data in. We are teaching the data how things are. And then the line is we are trying to make a prediction based on the model that we have created, the lean model. And then the line are printing out how well the model performed with the prediction. Yes. So we move on to the logistic regression. You notice that for the linear regression in the third, and we saw that the model that was called was linear regression. The linear regression model was called. And for logistic regression, it's basically the same thing for the first line and the second line. So this one is an iris dataset. So for the first one, that's the linear regression. To result is going to predict a continuous number. So for example, for the diabetes, they have levels. So it's going to bring out a number to tell the level of diabetes that you have. But for the one, because as I mentioned, the logistic regression is going to bring out probabilities. But in the end, those probabilities will have a threshold that can help you to categorize the results you got from the probabilities to discrete classes. Yeah. So for the logistic, the first line is the same thing, you are the data. The second line is the same thing, you are splitting the data. This time, we choose to do test size 0.3. So that means 10%, sorry, 70% is used to train and then 30% is used to test. And then we call the logistic regression model. And we set the iteration to be 200, and then we fit in the training data for both the features and then the target. And then we try to make a prediction with the model we have created. And then we are trying to print out accuracy of the model. So this is basically it. This is just a simple description of how the whole thing works. But if you notice, the difference we see at the top one and then the down one is for the linear regression is calling the linear regression model, and then for logistic regression is calling the logistic regression model. So that is it for today. I hope we learned something new. And time is fast spent, but if you have any questions, you can just go ahead and ask. me now. Is there any questions? Okay, in the absence of any questions, thank you for the opportunity. Obviously, we'll hand over to David.
Thank you very much, Miss Glory Akoto.
My pleasure.
So please, if you have any question, you can raise up your hand and ask. Since our resource person is here, if you have any question, you can raise up your hand and ask. You can unmute as well and speak. If you have any question for our resource person concerning what you have done today. Edu Jemfi, Ferdinand, Kweku Emmanuel. Please, if you have any question, you can unmute and speak. Please, can you hear me? Please, can you hear me?
Yeah, I can hear you, but I don't have a question.
Okay. So please, thank you very much for joining. So we'll continue with the session tomorrow as well with our week 4 section. And I want you to join us tomorrow as well. And also share the link to your friends to also join us as we continue our boot camp. Don't be the only partaker of this, but also invite your friend, your colleagues who need this to also enhance their technical skills and join us in this boot camp. So as we share the link on our pages, on our WhatsApp, do what to also share to your friends and invite someone. So tomorrow we will continue with our session, which will be our week 4. So please do what you invite someone, as I've said earlier. And also we'll be sending an evaluation form to this very to the chat box as well as our Telegram pages for you to fill concerning this session. If you have any feedback, maybe you cannot speak here, but you can fill the form to help us get feedback so that in our next session we can improve on that and work out our weakness. So I'm sending the evaluation form now. Maybe if you can fill now or you fill later, which will be sent to our Telegram page as well. You can do that. So as we wait, I want 1 or 2 people to share what they have learned with us for today's session. Any one of us or any 2 people, 1 or 2 people to share with us what they have learned in this session. So please, you can unmute and speak if you are ready. So please, who is sharing with us what he or she has learned in this section? Kindly share with us what you have learned in this section. One or two people to share with us. Edu Jemfi, Emmanuel. You can share with us what you have learned in this section. Or if any one of us, of these, maybe Glory, if you can elaborate one or two things, your final say on this session. If Wisdom 2 is there, you can also share something with us.
Oh, my final words are for us to understand this particular field of AI and data science, we just need a lot more practice and learning. Because if this is the first time you heard all these things, then certainly you'll be a little bit confused. So I'm just encouraging you that you can continue learning more about them, and with consistency, you'll be okay.
Okay, thank you very much. Consistency. Consistency. I know that for some of us, this is our first time, or maybe this will be a second time of hearing or knowing of machine learning. So, as our resource person said, we should try our best to put in the effort, either by 1 hour, 2 hours, 30 minutes, just going by the day to delve deeper into this aspect of machine learning. Without wasting my time, I like to bring to our notice that we have ended today's session. And thank you once again for joining us in this session. The feedback form is in the chat box. The feedback form is in the chat box, so kindly access it and fill the form for us to make improvements in our next section. So kindly access the evaluation form in the feedback in the chat box so that you can help us to prepare adequately or to prepare well for the next session and our previous meetings as well. So thank you, Emmanuel. Thank you, Edu Jemfi. Thank you, our resource person, and my partners here, Wilson Kruma, Wisdom, Jim, and the others. Thank you for joining, and God bless you. Do enjoy your evening, and we shall meet tomorrow to continue our session. See you all.